Hello everyone, welcome back to my YouTube channel. This is Kirtana, currently pursuing my second SEM BE in Electronics and Communication at Sri Venkateshwara College of Engineering, Bangalore. Today, in this presentation, I'll be presenting you all a topic related to basic electronics. Before moving on to the main topic, requesting you all to join me until the end of this video. So today's topic is operation of half-wave rectification. Before knowing about to the operation of half-wave rectification, let us know what is rectification. Rectification is one of the most important diode applications. Rectification is the conversion of a sinusoidal AC waveform into single polarity half cycles. Rectifications may be performed in half-wave or full-wave rectifier circuits. In this figure, we can observe the AC waveform is being converted into DC ones. A DC power supply converts a sinusoidal AC supply to DC by rectification and filtering. The filtering process normally involves the use of a large reservoir capacitor, which charges to the peak input voltage level to produce the DC output. The capacitor partially discharges between peaks of the rectified waveform, and this results in a ripple voltage on the output. The ripple can be reduced by the use of RC or LC filters. Now let's move on to the half-wave rectification, which is our main topic. In half-wave rectification, there are two cycles, positive half cycle and the negative half cycle. So first, let's look into the positive half-wave rectifier. An alternative input voltage is applied through a transformer T1 to a single diode connected in series with a load resistor, that is RL. The transformer is normally necessary to DC isolate the rectifier circuit from the AC supply. The diode is forward biased during the positive half cycles of the input waveform and reverse bias during negative half cycles. Substantially, current flows through R only during the positive half cycles of the input. For the duration of the negative half cycles, the diode behaves almost as an open switch. The output voltage waveform developed across RL, that is load resistor, is a series of positive half cycles of alternating voltage with the intervening very small negative voltage level produced by the diode reverse saturation current. Now let's understand this by pictorial representation. Here we can see in the first figure the transformer coupled half-wave rectifier circuit. So here the transformer is coupled with the half-wave rectifier circuit. We get the output in the only positive half cycles. Now we can see the operation of half-wave rectifier. So here during the positive half cycle, the diode behaves as a forward biased. When the current flow through the circuit, diode behaves as a forward biased, and in the output we get only positive half cycles. During the negative half cycles of the circuit, when the current passes, diode behaves as a reverse biased and it almost acts as an open switch. Hence current does not flow and we do not get any output waveform. Instead of we get a linear line. This is known as alternating current, that is AC waveform. In this waveform of half-wave rectifier, Here we can clearly observe how the alternating current is being produced, that is, positive half of the cycle. During the positive half of the cycle, D1 is forward biased, hence we get only positive half cycle. During the negative half cycle, diode is reverse biased and we does not get, hence we get a linear output. Now looking into the negative half wave rectifier. Negative half wave rectifier is similar to the positive half wave rectifier. Just here we need to change the diode direction, that is the diode polarity. Reversing the diode polarity in the circuit, the negative half cycle of the AC input is passed to the load resistor. Consequently, the peak output voltage and current are negative quantities. When the transformer output waveform is at its peak positive level, the load waveform is actually a peak negative quantity because output terminal B is negative with respect to the grounded terminal A. Diode is reverse biased during the negative half cycles of the transformer output, so the load voltage is 0. A negative half cycle, that is a negative half wave rectified waveform, can be generated simply by grounding the positive output terminal of a positive rectifier circuit. One of the rectifier circuit output terminals may be grounded only when the transformer is present to provide complete DC isolation from the AC supply. So here we can observe how the negative half cycle is produced. When the current is passed, the diode reverses the polarity, and during the negative half of the cycle we get the negative cycles, and during the positive half cycle we does not get any waveform, instead we get a single line. Hence positive half cycle is similar to negative half cycle. Only here the polarity of the diode is changing. The working procedure remains same. Looking into the last one, that is few of the formulas. The first one is peak output voltage. VPO is equal to VPI minus VF. To calculate load current, the formula is IL is equal to VPO divided by RL. And the third one is VR is equals to PIV. The fourth one is VRMS is equal to VPI divided by root 2. These are few formulas to solve the problems. Thank you for watching. Please do like, share and subscribe my channel.